Let's look at this awesome question. Now, this will make us really happy. A particle is released from height capital H. At certain height, its kinetic energy is 2 times of its potential energy. At certain height, its kinetic energy is twice of its potential energy at that height. Okay? The height and the speed of the particle at that instant are. So we have to calculate what is height and what is speed of the particle at that instant. Again, let me repeat the question. The particle was at height capital H from ground. If we consider the potential energy at ground reference to be 0, we can say the potential energy at this height is mg capital H. And the initial velocity was 0, so initial kinetic energy was also 0. Now we release the particle. When the particle comes down, at certain height, its kinetic energy was found to be twice its potential energy. Its kinetic energy was twice of its potential energy at this particular height. Let's say the height is small h. We have to find what is the value of small h, and we also have to find what is the speed of the particle at this instant. What is v? What is small h? This is the question. Now, are we ready to solve it? Yes. How do we solve it? Well, first of all, I will calculate what is final kinetic energy at this position and what is the final potential energy at this position in the terms of small h. And when we use this condition given in the question, we will get the value of small h. And from that, we will calculate what is the speed. Now, let us go to the actual process. We can say that the final potential energy U final at this height is small mg h. Okay, now let us go to the conservation of mechanical energy. We can say the sum of initial kinetic energy and the potential energy is equal to the sum of final kinetic energy and the potential energy. Okay, so initially we can see that the kinetic energy was 0, particle was released from rest. And initially the potential energy was mg capital H, not small h, capital H. It was at a height capital H. Okay. And finally, we can say the kinetic energy is K final and the potential energy at this height is small mg h, mg small h also. So, we can say the final kinetic energy is coming out to be mg capital H minus small h. Wow, awesome, fantastic. Another way to get this kinetic energy is loss in potential energy is gain in kinetic energy. Got to repeat it. Loss in potential energy is gain in kinetic energy. Okay, how do we do that? Well, let us see. Loss in potential energy is due to this displacement, right? And what is this displacement? This displacement is capital H minus small h. Can you see it? Yes. So what is the loss in potential energy? It is mg capital H minus small h. Okay, that's what I have written. Mg capital H minus small h is written over here. This is loss in potential energy. And gain in kinetic energy is the final kinetic energy K final minus the initial kinetic energy which was 0. So K final minus 0 is K final. Okay. So that's how we get the final kinetic energy. Fine. Now, how do we calculate small h? Well, let us look at this condition given in the question. According to this condition, we can say that the final kinetic energy, which is mg capital H minus small h, is equals to twice of final potential energy. What is final potential energy? It is mg small h. Now, can you see that mg is cancelling out mg? Tichu, and we get the value of small h to be capital H by 3. Wow, awesome, fantastic. Now it's time to calculate what is this speed v. What is v? Now, to calculate v, I will go back and I will just say that at this height small h, the value of kinetic energy final was equal to mg capital H minus small h, right? Right. Now the final kinetic energy at this position can be written as half mv square. Is it or not? Yes, okay, we can write that. Now, first of all, this mass is cancelling out. Tichu. And the value of v, we can get it like this. Whole under root of 2g capital H minus small h. So simple. And now, do you remember what is small h? Small h we have calculated. Small h came out to be capital H by 3. Oh, we remember that. So we can go back and see small h came out to be capital H by 3. Okay. Now, we are using this to calculate V. So, if we put the value, we are getting V is equals to whole under root of 2G 2 capital H by 3. And this can be written in different style. It is 2 times whole under root of G capital H by 3. Okay, we also get V and we also get small h. So we complete our solution. And now we can mark option B as the right answer for this question. Let's have a look at this awesome question. A block of mass 2 kg initially at rest moves under the influence of a time-dependent force. So force is dependent on time. Force vector is given to be 4t I cap. The power developed by the force in 2 seconds is. So we have to tell what is the power at t is equals to 2 seconds. Now, power is asked. Do you remember the formula of instantaneous power? Yes, we do. Power is nothing but force vector dot velocity vector. Right. Now, let us consider this block. This block is of mass 2 kg and initially it was at rest. U was equal to 0. And we started applying the force in the positive x direction. This is the force. Now, what do you think about the velocity? What would be the direction of velocity? You say the velocity will be in the direction of force because initially the velocity was 0. So it is the force which is providing the acceleration. As the acceleration is also in the direction of force, the acceleration is in positive x-axis and this will give the velocity in positive x-axis. So velocity is in the direction of force. Very nice. Now, when force and velocity are in same direction, we can say the power will be Fv. So simple. But we need what is this force as a function of time? What is this velocity as a function of time? Force as a function of time is given. It is given to be 4t. But we don't know what is velocity as a function of time. Oh, we can find that out. We can actually find out what is acceleration as a function of time. Acceleration is simply force divided by mass, isn't that? Now, what is force? Force is 4t. And what is mass? Mass is 2. Oh, so we get acceleration as 2t. We got acceleration as a function of time. Great. Now, we can just simply say that A is nothing but dv by dt. And this is equal to 2t. This is a differential equation. Don't be scared. We will just solve it. We will solve it using our friend Snake. So Snake, please come. Please help us. We want to integrate. Okay, the Snake says, here I come. But I need the lower limit and the upper limit. So what is the lower limit of this integration? What is the speed at t is equals to 0? What do you think is the speed at t is equals to 0? It was given to be 0, right? Okay, so let's put the speed 0. Now, at time t, I consider the speed to be v. So when we integrate using this limit, you can see we are getting v is equals to t square. Wow! So we got speed as a function of time, v is equals to t square. Right. Now we know force as a function of time. We know speed as a function of time. So we can actually go ahead and calculate the power. Power is nothing but force times speed. And in this case, we have force as 4t and speed as t square. So we are getting 4t cube. Power is 4t cube. Let me rewrite it. Power is 4t cube. So we have everything as a function of time. Now, if you give me time, I give you everything. So you give me t is equals to 2 seconds. Okay. So power at t is equals to 2 seconds, at t is equals to 2 seconds, the power comes out to be 4 times 2 cube. 4 times t cube is 4 times 2 cube. So 2 cube is 8. 4 8s are 4 8s are 32. So power is 32 watt. And we can see that option B is the right answer for our amazing question. Let's have a look at this awesome question on Newton's laws of motion and friction together. A block is moving on an inclined plane making an angle 45 degree with the horizontal, and the coefficient of friction is mu. So there is a beautiful inclined plane. The angle of inclination is given to be 45 degree. This is how our inclined plane looks like, 45 degree angle of inclination. And on this inclined plane, there is a beautiful block. Now let's look at what the question is saying. The question says the force required to just push it up the inclined plane. The force required to just push it up the inclined plane, let's say this force is F1. So this force required to just push it up the inclined plane is 3 times the force required to just prevent it from sliding down. So this force F1 is 3 times of another force F2, which is required to just hold the block on this inclined plane. So in the first case, we are actually pushing this block up. In the second case, we are preventing it from sliding down. And F1 is given to be 3 times of F2. Great. If we define n is equals to 10 times of mu, then n is. So we have to find this number n, which is actually 10 times of mu. So to find n, we must know what is mu, right? So we will find out what is mu, and then we will get the answer. We will find out what is n, which is 10 times of mu. So simple. So let us see the two cases. In the first case, we are actually pushing this block up the inclined plane. And if we want to push this block up the inclined plane, the friction force must act in the downward direction or down the inclined direction, right? Right. So let us see what will be the free body diagram of this object. Now here are all the forces on this object. Now I usually prefer the symbol normal reaction instead of R because we are habitual with normal reaction. So let's just use N for this normal reaction. And we can see friction force is acting downwards, and we have already broken mg into two components. One component mg sine 45, this component is down the incline, and the other component mg cos 45 is perpendicular to incline. And we can see normal reaction will be equal to mg cos of 45 degree. Very nice. Now let us say the acceleration of this block A1 is actually 0 because we are just pushing it up. So we can push it up without any acceleration also. So the force F1, we can get the equation of F1 like this. F1 minus, in the down the inclined direction, we have two forces, mg sine 45 and friction. So we subtract them from F1 and we get m times A1. And we know A1 is actually 0. So we can just replace this by 0. Now, here comes the value of friction force. This is important. Now, if we are just pushing this block up the inclined plane, what do you think is the nature of friction? Is it static in nature or kinetic in nature? We are pushing this block. The block is sliding. What is the nature of friction? Static or kinetic? Yes, it is kinetic because there is some slipping. And we can say the value of kinetic friction, Fk, is equal to normal reaction times mu, right? Right. So this is mu mg cos of 45 degree. Okay. So let's just place the value of f over here. We have mu mg cos of 45 degree. Good. Now let me just rewrite the equation. The force F1 will be equal to mg sine 45 degree plus mu times mg cos 45 degree. And you know, sine 45 is 1 by root 2, cos 45 is also 1 by root 2. So we can finally get the equation for F1. This is mg by root 2 plus mu mg by root 2. This is equation 1. Great. We have solved the first case. Now let's go to the second case. In the second case, this person is just preventing this block from slipping. The block wants to slip in the downward direction. So the man have to apply a force in the upward direction. This force is F2. Okay. Now what do you think will be the direction of friction? The block wants to slip in the downward direction. So the friction force will prevent any slipping. Friction force will act in the up the inclined direction. But this friction force is not enough to prevent the block from slipping. So that's why this man comes into the picture and the man applies the force F2, and this F2 and friction force together take the block at rest, and then this block does not accelerate. Great. Now let us see the free body diagram. And the free body diagram of this object will look like this. Again, instead of R, I will use the symbol N because we are habitual with this symbol N. Okay. Now, friction force is Fs. It is static friction. Because the block is not slipping, static friction will be acting. And let us see what equation we are getting. We are getting F2 in the upward direction and friction force also Fs in the upward direction. And this is equal to mg sine of 45 degree. And we can just rewrite the equation like this. F2 is equals to mg sine 45 degree minus Fs. Okay. Now, if we want the minimum value of F2, if we want the minimum force to prevent the block from slipping, then we must have maximum value of static friction, right? Right. So, what do you think is the maximum value of static friction? F static friction maximum. What is the maximum value of static friction? You say it is the limiting value. It is normal reaction times mu s, right? Now, normal reaction is mg cos 45 degree and the coefficient of friction is given to be mu. So, we have mg cos 45 degree times mu. This will be the value of Fs in our equation. Now, when we place this value, we get this equation. F2 is equals to mg sine of 45 degree minus mu mg cos of 45 degree. Sine 45 degree is 1 by root 2. Cos 45 degree is 1 by root 2. So we have this equation 2. And equation 2 looks great. Now we had the value of F1 and we had the value of F2. Let's look at them together. So F1 is this, F2 is this. And in the question, it was given that F1 is equals to 3 times of F2. And what was asked? The value of some number n was asked. So let's see what was given. F1 is equals to 3 times of F2. And the value of this number n has to be determined. And to determine n, we have to get the value of mu first. Now let's see what is this mu. So let me just use the value of F1 like this. Mg by root 2, and I take something common. Mg by root 2 was common. So 1 plus mu is in the bracket. This is F1. And on the other side, we have 3 times of F2. Now I will write F2 in this style. I will take something common. Mg by root 2 is common. And the thing which is left is 1 minus mu. Wow! Mg by root 2 cancels out mg by root 2. And we get the value of mu. We are getting 4 mu. 4 mu is equals to 2. So, mu means half. Okay, so mu is half. And when mu is half, can you find the number n? Yes, very easy. So this number n is 10 times of half. And this number n is actually 5. So we got our answer. N should be 5, and we can mark option C, 5, as the correct answer for our question. Let's have a look at this awesome question. A body slides on a frictionless surface A to B, and the velocity of the ball at A is 5 meter per second. Its velocity at B is. So what is given? The speed at A is given, it is 5 meter per second. Good? Good. And when the ball comes down like this, shoo, it reaches point B. And the speed at B is asked in the question. And we can see there is some height difference. Actual height difference is 2 meter. And we can easily solve this question if you know the conservation of mechanical energy. Now, when do we apply this conservation of mechanical energy? When there is no net work done by external force. By external force, we mean a normal reaction in our case, and normal reaction we can see is not doing any work. Friction is absent in our case, so we are lucky we can apply conservation of mechanical energy. Now, we need the initial potential energy and the final potential energy, right? Right. So, let me just define a level at ground to be having zero potential energy. So, this level on ground is all the points on this level which lie on the ground. We can say all these points have zero gravitational potential energy. And we can see that point A is not on the ground, it is at some height. So, there will be some potential energy at A, right? Right. So at A, potential energy is mgh, and m is the mass of the ball. So we can say initial potential energy is mgh. By the way, what is h? H is 2. So let me just write mg into 2. And kinetic energy initial. Do you remember that the ball initially have some speed? U was given to be 5. Oh, now we can say the initial kinetic energy is half m5 square. Okay. And what about the final potential energy? Well, as the ball reaches the ground, at ground level, the potential energy is 0. So, we can say the final potential energy at ground is 0. We have defined this level. This is our reference level. And finally, the kinetic energy final, we can say it is half m vb square. Very nice. Now we can just cancel out m, and we can see that vb square is equal to 20 plus, uh, here we have 25 by 2, and we multiply this entire thing by 2. So this will give us vb square. And we can see 40 plus 25 is basically 65. So VB square is 65. This means VB is equals to under root 65. Well done. We have got the final speed at point B, and it is under root 65. Now let us see the options. We can see that option B is the right answer for our question. Here is an incredibly interesting problem, and I'm sure we are going to enjoy it. System shown in the figure is released from rest. Now, this 5 kg block you can see was actually held in the air at rest, and we release it now. Pulley and spring is massless and the friction is absent everywhere. Like always, speed of 5 kg block, speed of this 5 kg block when 2 kg block leaves contact with the ground. So we have to tell what is the speed of 5 kg block when the other block, which is of 2 kg, it just lifts up from the ground. And the value of k is given to be 40. Now, let me again re-say the question. Here we are holding 5 kg block and we actually release this block. Now you can see there will be some extension in the spring, right? Right. And this extension in the spring causes some tension to be developed in the rope. So there is some tension developed in the rope. And this tension is responsible for lifting the other 2 kg block. So, when the 2 kg block just lifts up, we have to tell what is the speed acquired by the 5 kg block. This is a really cool question. We have to find the speed of 5 kg block when the other 2 kg block just lifts up. Now, I hope the question is clear up to now. Okay. Now, let us say when the 2 kg block just lifts up, there is some extension X in the spring. There is some extension X in the spring. And we can just draw the free body diagram of 2 kg block when it is just about to lift from the ground, or it has just lifted from the ground. Anyhow, we can see the normal reaction on 2 kg block becomes 0. Yes. Why this normal reaction is 0? Because it just get lifted up from the ground. And we can say if acceleration of 2 kg block at this point is 0, tension is equal to mg, right? And why did we have this tension in the rope? Because there was some extension in the spring. What was the extension in the spring? Well, if we consider X to be the extension, we can say the tension force is equal to the spring force Kx. Tension force is equal to the spring force, which is Kx at this point. And from this we can see when Kx is equals to mg, the value of x is mg by k. Mass is 2 kg, so we have 20 because g is 10, mass is 2, and the value of k is 40. So we have 20 by 40 as the extension x, and this is nothing but half meter. So we finally got what is the extension in the spring. But unfortunately, this extension was not asked in the question. What was the question asking us? Question was asking us to find the speed of 5 kg block at this point. Now, how to get this speed? Well, I will show you a trick. Can you see this 5 kg block, spring and earth as a single system? Can you imagine this 5 kg block, spring and earth as a single system? Yeah, we can do that. So, if we consider this system, you can see just as we release this 5 kg block, it comes down. So there must be some loss in gravitational potential energy, right? Right. And this loss in gravitational potential energy actually converts into the kinetic energy of this 5 kg block and the spring potential energy. I will repeat it again. So we are applying conservation of mechanical energy. So let us just say at this particular level, we can define the potential energy, the gravitational potential energy at this level to be 0. Let's just assume the gravitational potential energy at this reference level to be 0. Fine? Fine. Now we can say initial mechanical energy is equal to final mechanical energy. Good? Good. Now, when 5 kg block was at this particular location, when 5 kg block was at this particular location, what was the gravitational potential energy? You will say mgh. What is h? H is equal to x. Fine. So gravitational potential energy is mass, which is 5 g times x. Good. So this was gravitational potential energy. Now, tell me, when the block was at this particular location, what was the initial kinetic energy? The block was at rest. No kinetic energy. Kinetic energy is 0. Agreed. Now tell me, what was the initial spring potential energy? Oh, spring potential energy. that is also equal to 0 because earlier there was no extension in the spring. Nice. So this means 5gx was the total initial mechanical energy, right? Right. Now this thing is equal to final mechanical energy also because this mechanical energy is actually conserved. Now let's see finally what happens. Finally, this block 5 kg block comes down and it comes to a level at which we are defining the gravitational potential energy to be 0. So finally, the gravitational potential energy at this particular point is 0, right? Right. So we are having the total mechanical energy in the form of kinetic energy of this block, which is half mv square, and the spring potential energy. Some energy is stored in the form of spring potential energy at this point also, because at this particular point there is some extension in the spring. Can you see the extension in the spring? Yes. So what is the spring potential energy? It is half k x square. Yippee! Now, let me again re-say what is happening. So there was some loss in gravitational potential energy. It is equal to 5gx. And this loss in gravitational potential energy converted into kinetic energy and spring potential energy. So there was some increase in kinetic energy, there was some increase in spring potential energy. So this is what happened. Now we know what is the value of x. X is equals to half meter when the other 2 kg block is being lifted up. Okay, so let's just put the value of x and let's find what is the value of v. After all, the speed of 5 kg block was asked in the question. So let's just solve it. G is equals to 10 and x is equals to half. So we are getting 5 times 5, which is 25. And over here we have 5 by 2 v square, and we just add half k. K is basically 40. So we have half k x square. X is equals to half. So x square is 1 by 4. So what are we getting? We are getting something interesting. We are getting that 5 by 2 v square is equal to 20. This means v square is equal to 40 by 5, which is equal to 8. And v is coming out to be 2 root 2. This means v is coming out to be 2 root 2 meter per second. We finally got the speed of 5 kg block. Incredible. So let us just mark option B as the correct answer for our question.